Hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Hello, I would like to learn more about Retrieval-Augmented Generation RAG and its applications for large language models. Could you please provide an overview of the main findings and contributions in your survey study on RAG?
Sure. In our survey study on Retrieval-Augmented Generation, RAG, we explored how RAG techniques can enhance the performance of large language models, LLMs, in various tasks. We found that by incorporating a retrieval step before the generation step, RAG can improve the accuracy and relevance of the generated outputs. One important finding is that using a retrieval module in RAG can help address the issue of lost-in-the-middle phenomenon. This refers to the inefficiency that arises when a single retrieval is performed without considering the context relevance. By using the retrieved information as a context for generation, RAG can generate more accurate and contextually relevant answers. We also discussed different methodologies in RAG, such as GenRead and SelfMem. GenRead replaces the retriever with an LLM generator, finding that LLM-generated contexts often contain more accurate answers due to better alignment with the pre-training objectives of causal language modeling. SelfMem, on the other hand, creates an unbounded memory pool with a retrieval-enhanced generator, using a memory selector to choose outputs that serve as dual problems to the original question, thus self-enhancing the generative model. In terms of evaluation, we discussed the use of metrics such as hit rate, MRR, mean reciprocal rank, and NDCG, normalized discounted cumulative gain, to measure the performance of the retrieval module. For generation quality, we examined the assessment of coherence, relevance, and faithfulness of the generated answers. Overall, our survey study highlights the potential of RAG techniques in improving the performance and effectiveness of LLMs and provides insights into the methodologies and evaluation metrics used in this field.
That's fascinating. It seems that incorporating retrieval modules in the RAG framework can address some of the challenges faced by large language models. Can you elaborate on the different RAG paradigms you mentioned, such as naive RAG, advanced RAG, and modular RAG? How do these paradigms differ in their approach, and what advancements do they bring to the field?
According to the survey study on RAG, there are three main paradigms in RAG research: pre-training, fine-tuning, and inference. 1. Pre-training. This paradigm focuses on training large-scale language models on vast amounts of text data. The goal is to enable the LLM to learn the statistical patterns and linguistic knowledge present in the data. Pre-training is the initial stage where the LLM learns general language understanding. 2. Fine-tuning. Once the LLM is pre-trained, it undergoes fine-tuning to adapt it for specific tasks or domains. Fine-tuning involves training the LLM on a smaller data set that is more specific to the desired task or domain. This helps the LLM to specialize and improve its performance on targeted tasks. 3. Inference. In this paradigm, the pre-trained and fine-tuned LLM is used to generate answers or responses to user queries or prompts. The LLM utilizes its learned knowledge and understanding to generate relevant and accurate information. Inference is the stage where the LLM is utilized in real-world applications. These paradigms differ in their approach and advancements in the field. Pre-training focuses on training LLMs on vast amounts of data to learn general language understanding. Fine-tuning takes the pre-trained LLM and adapts it for specific tasks or domains to improve performance. Inference utilizes the pre-trained and fine-tuned LLM to generate answers or responses in real-world applications. Advancements in the field have seen a shift from solely focusing on pre-training to a hybrid approach that combines the strengths of pre-training and fine-tuning. This hybrid approach has been shown to improve the performance of LLMs. Additionally, there have been developments in evaluation benchmarks and tools to measure the capabilities and performance of RAG models. These advancements help in understanding the strengths and limitations of RAG models and drive further innovation in the field.
Thank you for the detailed explanation of the different paradigms in RAG research. It's interesting to see how pre-training, fine-tuning, and inference work together to improve the performance of large language models. In terms of the retrieval, generation, and augmentation techniques used in RAG frameworks, What are some of the state-of-the-art technologies and advancements that have been incorporated into each of these components? How do these advancements contribute to the overall effectiveness of RAG systems?
In the field of RAG, Retrieval-Augmented Generation, there have been several state-of-the-art technologies and advancements incorporated into the retrieval, generation, and augmentation techniques used in RAG frameworks. These advancements greatly contribute to the overall effectiveness of RAG systems. One of the key advancements is the introduction of large language models, LLMs, such as GPT-4. LLMs are pre-trained models that have been trained on vast amounts of text data, which allows them to have a deep understanding of language and generate high-quality text. These models serve as the generation component of RAG systems and greatly enhance the quality and fluency of the generated text. Another important advancement is the integration of retrieval techniques. Retrieval techniques involve retrieving relevant information from a large knowledge base to augment the generated text. This retrieval component allows RAG systems to have access to a vast amount of information, which can be used to provide accurate and contextually relevant responses. This enhances the overall coherence and relevance of the generated text. Furthermore, there has been a shift towards a hybrid approach in RAG systems, which combines the strengths of both retrieval and fine-tuning processes. Fine-tuning refers to the process of further training the pre-trained language models on specific tasks or domains. By combining retrieval and fine-tuning, RAG systems can leverage the benefits of both approaches, resulting in improved performance and adaptability to different tasks and domains. These advancements in retrieval, generation, and augmentation techniques contribute to the overall effectiveness of RAG systems by improving the quality, coherence, and relevance of the generated text. The integration of retrieval techniques allows RAG systems to access a vast knowledge base, enabling them to provide accurate and contextually relevant information. Additionally, the use of large language models enhances the fluency and naturalness of the generated text. The hybrid approach further improves the adaptability and performance of RAG systems, making them more effective in addressing evolving requirements and achieving heightened controllability.
Thank you for providing insights into the advancements in retrieval, generation, and augmentation techniques used in RAG frameworks. It's impressive to see how the integration of large language models, retrieval techniques, and the hybrid approach can improve the overall effectiveness of RAG systems by enhancing the quality, coherence, and relevance of the generated text. In your survey study, you mentioned the introduction of metrics and benchmarks for evaluating RAG models. Could you elaborate on these metrics and benchmarks? How do they help in assessing the performance and effectiveness of RAG models?
In our survey study on RAG, we discussed the evaluation framework for RAG models, which includes metrics and benchmarks to assess their performance and effectiveness. These metrics and benchmarks provide quantitative measures to not only gauge the performance of RAG models, but also enhance our understanding of their capabilities in various evaluation aspects. One of the prominent benchmarks we discussed is RGB, Recall, Generation, and Blending, which focuses on evaluating the essential abilities of RAG models. RGB assesses the model's ability to recall relevant information from the input documents, generate accurate and coherent answers, and blend the retrieved information to provide comprehensive responses. Another benchmark we mentioned is Recall, which evaluates the model's ability to accurately recall relevant information from the input documents. This is important because RAG models rely on retrieving information from external sources, and the ability to retrieve relevant information is crucial for generating accurate answers. In addition to these benchmarks, there are also automated evaluation tools like Ragus, Aries, and TrueLens. These tools employ LLMs, language models, to adjudicate the quality scores of RAG models. They contribute to the assessment of RAG models by providing objective measures of their performance and effectiveness. Overall, these metrics and benchmarks collectively form a robust framework for the systematic evaluation of RAG models. They help us assess the performance of RAG models in terms of their ability to recall relevant information, generate accurate answers, blend information, and provide comprehensive responses. By using these evaluation tools, we can better understand and optimize the performance of RAG models in various application scenarios.
Thank you for explaining the metrics and benchmarks used in evaluating RAG models. The RGB benchmark, along with metrics like recall and the use of automated evaluation tools, provides a comprehensive framework for assessing the performance and effectiveness of RAG models in terms of their ability to recall relevant information, generate accurate answers, and blend retrieved information. This systematic evaluation approach helps to optimize and improve the performance of RAG models in different application scenarios. In your survey study, you mentioned prospective avenues for research in the field of RAG. Could you elaborate on these prospective avenues and the potential challenges that researchers may face? How can further research in these areas contribute to the development of RAG systems and their ecosystem?